Okay, going to be looking at video recorder mechanisms, how they work, and how we might as well start by getting familiar with them, what all the parts are. This is one rather rusty old one, early front loader from about 1983. This is pulled out of a Sharp 381 or VC381. That's what was known as the 300 series. So pretty much any Sharp VCR that's a 300 and something will use one of these, and these mechs I think were almost identical in the early ones, like the 9300s. If we go back to even earlier VCRs, the very early ones, which not many sold because they were very expensive, late 70s, maybe into the early 80s, actually had mechanical mechanism control. They're what is known as the piano keys. Out of the front of the machine or on top of it will be great big buttons that you press, mechanical ones which actually actuated levers and stuff in the mechanism, much like a cassette player, or at least a non-logic controlled cassette player. They were quite expensive machines. In the later, that was like the Sharp, probably I think the 6300 or something, some of the early Nationals and stuff, the Sanyo, I think it was an 8300, VTC 8300, early beta machine. But they quickly, coming into the 80s, started going to basically the equivalent of a Logic Touch cassette player, so it all just was push buttons on the front, little electronic switches that you just pressed. The Sharp 8300 was a bit of an odd one. There was a 7300, it was a great big old machine. I didn't see many of those. I think they were similar to the 8300s in that they had solenoids, so there was kind of a touch or a step between the old push button piano key type, where the buttons would actually do a lot of things directly by mechanically moving things, and they made that more of a push button version, an electronic logic controlled machine, by putting solenoids in place of the buttons, but you still had all these big electromagnetic switches underneath that basically pushed on the same things the keys would have pushed on. There weren't a lot of those machines around. They did have trouble with the solenoids and dry joints and all sorts of things in them. But again, not that many sold, because that would have been maybe 81, 82 sort of era when machines were still expensive. Getting into the early 80s, or sort of more towards the mid 80s I should say, around 1983 it was sort of the boom in home video rental, probably because the machines got to the price that people could afford them, and they got a bit more modern, probably because they got cut out a lot of the expensive parts like solenoids and mechanical switching and stuff. So this is one of the early ones. There was the 9300. It was almost the same machine as these. These are a little bit later. Sharp sold an awful lot of these machines, possibly because these were front loaders at a time when a lot of people were still using top loaders. Really the only advantage of this front loading mechanism is that you can sit it on a shelf under your TV. You don't need access to the top of the machine, so you can just have the front. Grab it. You just have the front panel like this. You don't need any access above. That can all sit in a cabinet, and you can just put your tape in the front, and then we've got our electronic push buttons to do everything. This machine's been out in the weather, it's literally a barn find, this one, and it's in terrible condition, so that's why I'm going to pull this one to bits and then probably chuck it out, because it's somewhat save a few things out of it, but it's basically not much good. So basically the first part we've got obviously is the loading part itself. If it was a top loading machine, it's just a sprung mechanical thing. You push your tape in and you press it down and it latches. There's nothing more to it than that. This is a bit more complicated. Obviously we've got a door on the front. They can cause problems, not so much these metal ones, but with the pins and the springs that cause it to come back. The later ones are just plastic things, so a little bit of force and it'll snap the pin off the end. You've got to change the door. Really the next part of that is, as you push the tape in, there's a little switch here, which is this black bit here with the two wires on it, that detects. It's basically a cassette in detecting switch. So you have to make sure, if it's not loading the tape, if you're pushing it in and nothing's happening, first thing to check is this switch. Sometimes they would bend or the contacts would break or something in those, and you just wouldn't get any load. Obviously once that's detected that a tape's in, we've got a loading motor here, so this should start up. That goes in, basically that'll go via at least an IC, if not via the actual microprocessor itself, and that'll tell this motor to start winding the tape in. So that's got a belt on it. Of course, obviously, a belt can slip or fail, but you'll hear the motor running. This other bit here, where am I there? That's this gear here, or there's an inner part and an outer part. They were common in these because they got this metal spring around them and these little posts that snap off. Quite a common thing in Sharps. Let me just find a tape. So that gear was kind of used, so as we push the tape in, the mechanism goes in a bit, that switch gets pressed. That's that piece that can go away. And as it goes in, you can see this spring on this gear, this inner gear sort of rotating. So that's putting even more pressure on the spring, and eventually, being plastic, they would snap off. You'd occasionally get things like these gears could get chew or something if someone had been really brutal with it. I think this other switch here is for when the mechanism is actually down. That's like an in switch to say it's loaded. On later machines, usually with a plastic loading mech, in order to get rid of this switch and even the motor and stuff, there's no motor, no loading switch. What they do is there's a sensor lamp, or it's a LED in later ones, and there's two end sensors, and what you would do is, as the mechanism went in, it would block the light from the central LED to one or both of the end sensors, and that would tell the microprocessor that someone's trying to put a tape in, and that would start your load motor. But the load motor no longer was on the deck itself. That got moved down to often the capstan motor, or it could be another motor on the deck somewhere. Various different arrangements, but they basically try and use another motor in the machine to do it, rather than wasting money on putting a separate load motor. So these older machines, you'll find that one of the reasons they're more expensive is because they've got more motors in them. Obviously, every motor costs a bit of money to make quite a nice little precision motor like that. A lot of people made the mistakes with these old machines, undoing these screws you see here, trying to get the cassette housing out. But these Sharps, it's actually four little red screws down the bottom here. Oh, we've got two of them out at the moment, but these red screws are what hold the loading mechanism in. Most machines have some sort of similar arrangement. Later ones, it's usually just two screws at the back and two hooks at the front, and you can get the loading mechanism apart from the deck. So this is, I've got it unplugged. This normally has a plug in here that goes into the wiring harness, so you'd have to pull that plug as well. Then you've got the whole unit out. Pretty rare you'd have to fix them, but occasionally you would. But most of the time you'd just be getting this out of the way so you could work on something else. We've got an end sensor here. It's this little hole there. Every VCR has them. There's another one there. They're basically a photodiode, and they're activated from the tape itself. We've got a hole in the bottom here which a light, most of them had an LED in them, goes up inside. And when the flap's up, which it is because as the tape loads in, that lifts up. There's a hook part there, as you can see there. When I put that in the loading position, as that comes loading in, the little button here on the end is pressed, it comes in, and that basically just a solid bit of metal there lifts the flap. And when the flap is lifted, we've got to hold that end, and we've got to hold the other end, so that light that goes up inside the hole here actually goes right through the tape, or through the housing. It doesn't actually go through the tape. If this dark tape you can see in here, the oxided part with the recording on it, if that's in place, then no light comes out of either end. But if once this tape gets a bit further along, if you want to rotate one of these by hands, you've got to press this other little bit. There's a locking tab so that the reels can't move. If you try and turn them, they're locked. So that, I guess, if it's moving around, you're carrying it around, it doesn't get all loose inside. There's a pin on the deck here sticking up, so when the tape's loaded in, that presses the release for the brakes. And now we should be able to rotate this. Not always the easiest because of the amount of tension, but these will turn. And when we get back to the beginning of the tape, that is actually clear. There's, I don't know, maybe 30 centimetres of clear tape there. So if this tape's in rewind or play or whatever, and we get to the clear bit, which that'll be on this side because it's the supply reel. When that gets wound right at the end of the tape, or when we're rewinding on this side and this gets right down to the last bit of tape, the black will turn to clear and the light will come out of one of these holes, depending which end it is, which will put our light into one of these end sensors, a little photodiode which will conduct, and that'll tell the microprocessor that you're right at the end of the tape, and that'll quickly switch off whatever mode you're in. So if it's in play, it'll stop. If it's in rewind or fast forward, it'll instantly stop before, otherwise it'll get to the end of the tape and could potentially break it. So that's how they detect ended tape. So if you've got problems with that sort of thing, anything to do with it, maybe breaking tapes or something, pretty rare it ever did happen. Some machines won't load if the light isn't working or the end sensors aren't working, things like that. These Sharps, one of the most unreliable thing about these Sharp mechanisms is they kept using an incandescent globe in here. That's our sensor lamp. This was a common problem in these. Because it's an incandescent lamp, eventually it blows, or if someone moves the machine around, bangs it around a bit, that'll blow. If I got them in for servicing for other reasons, I used to just give them a flick usually, and because otherwise you guarantee the customer get the thing home and it'll be blown and they'll have to bring it back again. So I'd either just replace them each time, or you give them a little flick, and if it was on its last legs it would blow and you just change it. But it just wasn't worth the hassle, because it'd run fine for you, and of course by the time they got it home, bounced it around a bit more, bumped it around in the car or whatever, putting it back in the shelf, that thing would blow and you'd get a recall on it, so you didn't want that. They basically just, you could buy them with this base. Might get a shorter screwdriver, would be handy. But a lot of the time you just bought them, they were cheaper to buy with just the leads. So you undo this base and you unsolder the wires, pull them through, undo the few bits of wire there, then you've got to pull them out under here and then poke upwards, and that lamp will come out of that plastic housing, and you just put a new lamp in. I think they run at 5 volts or something, so I don't know if you can still get these lamps. May have to come up with another method of doing it. Even the old top-loading National VCRs and stuff of this era used a double-faced LED in there, so like 2 LEDs, sort of flat-backed ones with little lenses pointing each way, and they never failed pretty much, whereas these were quite a common problem. The next obvious thing, I guess, is our heads. This is the helical scanning head assembly, or drum assembly, head drum assembly I guess. It's got a little thing, this one's pretty knackered by the sound of it, it's not running too well, but basically it's got a motor, like a what do you call it, a servo motor with flat coils, and then a magnet in this metal bit that spins. That's a driver IC, so there's a few signals coming into that, I guess something to turn it on. There might have been a feedback speed, I think there's a Hall effect sensor and stuff in these for speed, and it's just basically a shaft going up through. You've got this big aluminium piece, you've got what's known as a lower drum, which is the stationary part here. There's actually a bracket underneath that, we'll pull that to bits later and have a look, but this upper part where there's that above my finger there where there's a slot, that's the lower drum, and then we've got the rotating part, which is the upper drum, or what is known as the video heads. It's got a little static strap here, just because it builds up a bit of static electricity while it's running. I don't think later machines really had that. I don't know if they had something inside, but you have to remove that if you want to do head change or anything. So that bit can be got rid of. And then basically we've just got, that's just another little aluminium cover. I'm not even sure why they had that on there. That was all done away with in later machines. Maybe just to stop those wires coming up. Yeah, probably is why, because these early machines had separate wires going down to the heads. So what we have here on the shaft, this actual aluminium piece comes off, leaving that bit of green circuit board and the metal shaft there. That's actually like a coil underneath that, so obviously the heads are spinning, but they're connected. So they've got like 2 flat coils down underneath here, and 2 wires from each side of the head go into sort of concentric rings, and then there's the other side of the coils which picks up the signal again, so it's basically so it can mechanically spin but still get the electrical signal through. We've actually got like a rotary transformer coupling the 2 bits, so that comes back out. The stationary part of that is in the lower drum, that comes back out through these connectors here which go to the head preamp. I'm not sure if that's an actual heater. Where have we got a dew? There's a dew sensor in these somewhere, and I can't even remember where it is. which is, oh, there it is. So all these video recorders, if you're moving from a hot building, or is it from a cold building to a hot building, it's been sitting in your car or something cold, and you bring it indoors, you'll get condensation, especially on these heads. And if you put a tape in it and it hits wet heads or damp heads, it'll just stick to them and the tape will get ripped to shreds or wrapped around and probably dirty the heads up and stuff. It'll destroy the tape usually. And so they have a dew sensor in these, which if that gets moisture on it due to condensation, it just means the machine will take maybe half an hour to warm up. I'm not 100% sure, but I get a funny feeling that might have actually been a heater in these, some sort of little heater element to try and hurry that process up. Usually if you've been working on one of these cleaning heads or something, you just got a hairdryer, or if the dew sensor came on and you've taken the top cover off, you just get a hairdryer and heat everything up for a bit, maybe a couple of minutes, and dew sensor should go out again. So I think that other bit may have been an actual heater in some of these early machines. The other heads we've got here, we've got an erase head here. So this just is a big blanket erase head, like getting a audio cassette player. It just erases everything off the tape. The other heads here are known as the ACE head, audio control head. So that's got its own separate erase head there. So some machines you could actually dub audio and stuff. I'm not sure if that's why they always did that. I think the other erase head pretty much erases everything off the tape. I don't think it leaves an audio track. It's the full width of the tape, but a lot of them did have an erase head here as well. And more importantly, we've got two little, it's like a large cassette head or two cassette heads in one, spread out, one head at the top, one at the bottom, and that detects, I forget which one, I think the audio, was the audio on the top? No, I think the audio is the bottom head, because I think when the top of the head gets chewed up, or was it the bottom that got chewed up? I'm trying to remember now. But one of those basically just gets the sound. If it's a stereo machine, like stereo linear, not stereo hi-fi, it'll have a stereo head there. The other one actually picks up pulses. So on the recorder on the tape is basically synchronizing pulses to do with the speed of the tape. So if it's recorded in one machine, it might be recorded at a slightly different speed as the tape goes through the capstan. And so this picks up the pulses and synchronizes the capstan motor speed to whatever the recording was. That's basically what your tracking control does. It adjusts just ever so slightly, just adjusts the speed of the capstan motor just to get them synced back up again, because you've got these long helical scans diagonally across the face of the tape. So they sort of go as the head comes up. Starts off, the heads are these little tiny pieces in here. You can see a little black hole right at the bottom where it joins onto where the moving part meets the stationary part, the lower drum. And that comes spinning around. I forget which direction these goes now. I think it goes this way because the tape's going that way. So it starts down low on the bottom of the tape and scans around, and it rising as it goes. So you get these big diagonal sweeps along the face of the tape. And yeah, I guess the speed, that's another independent speed. So the drum speed is one thing, but to get that synchronized up again with the drum, you obviously have to control the capstan a little bit, I think, to make sure everything lines up and it feeds through at the right rate for this scanning it. So that's why on the top of the tape, or the bottom, one or the other, I think top we have control pulses, and bottom we have audio track or tracks. There were a few of these machines, including I think the 386 version. This machine was a linear stereo machine, but they quickly gave way to proper hi-fi machines, which actually have another pair of heads on the main hi-fi, so they actually record hi-fi audio onto the tape helically, and they basically don't use the audio, or if there is an audio track there, it's just a mono one, just in case the tape's played in a mono machine. I'm not sure a hi-fi machine bothered putting down an mono audio track, but it probably did, just so it was compatible with other machines. So that's some of the main. That's the head part. That's the parts that do all the reading off the tape of the actual video and audio information. Other than that, it basically works very much like an audio cassette player. But the only difference is we've got a set of tape guides here that actually come up and actually pull the tape out of the case, and so they're right around this head. So it's got a nice long track it can scan as it's spinning. It's got the tape in place, so it's basically scanning, starting over here somewhere and coming around a whole piece of tape to there, and then the tape comes back around through our pinch roller and capstan, which pulls it through. So like a cassette player, all the pulling of the tape is done by the capstan and the pinch roller. These reels, they're used in fast forward and rewind. So in rewind, this one's pulling the tape through, that one just spins. In fast forward, this one does all the pulling of the tape. But in play mode, this one just sits there and just lets the tape, just rotates as the tape comes out. The capstan's doing all the work of pulling, and this one is just winding the tape back in the machine. So the famous chewing fault you get both with audio cassettes and video cassettes is due to this reel not rotating. And both of these, in every machine you'll have some sort of idler. This is this little wheel that can flick from side to side, and that's basically just sitting there free besides this spring that pulls it in. That pulls it onto what is known as a reel motor. There's a little pulley that it's pressed against. That's the actual motor itself underneath here. And all we have to do is change direction on this. There's a chip on the main board that basically switches the DC voltage, probably 12 volts or something, I don't know if they say, but it switches it, the polarity, basically reverses it between the pins. And when the motor goes one way, it'll actually just pull this idler by a friction. It'll pull it across, as long as it's free to move well, and as long as the surface of the rubber tyre is good in this type of machine. Later ones it's just a gear, but either way, this, when the motor changes direction, it'll flick that to one side or flick it to the other side, and then this wheel basically gets sort of jammed between the pressure of the motor pulley and the actual reel itself. Like I say, in later ones that'll be toothed wheels. We'll have a look at a later Sharp machine in a minute. That was the other major problem with these Sharp machines, was this idler would wear out all the time. It's got this plastic sort of pulley thing on the end of the motor shaft, and they tended to get a bit rough. They seem to wear them out awfully quick in these machines, more so than just about any other machine. They did make it like a brass pulley thing you could put on, or sleeve on the motor, which had a sort of crosshatch pattern in it, which tended to grip a bit better. I don't know if it actually made them last longer or it just gripped them better, so they kind of lasted longer because it could get a hold of a worn ones better. But yeah, that's how that works. That's a common problem for causing chewing. If you're getting tapes chewing, usually what happens is, because the tape's pulled out to here, it's got these loose bits. As soon as you hit stop, these two tape guides, they retract back to here, and as they're doing it, this needs to flick across and wind the tape back into the case, because there's two big loops of it out. We can have a look at that later. So usually the idler will fail to work. It'll often still work okay in play, but if it's chewing in play, you'll get tape coming out here somewhere. That's because this isn't taking up, again probably due to the idler, or the motor isn't running. And every time you hit stop in these early VHS machines, these retract, tape guides come back, there's two loops of tape there. As they come back, this needs to be put in tension on, so all that loose tape gets wound back into the case. Then the case can be ejected, because if we have tape hanging out when we're like this tape's not much good, so it doesn't really matter. I can probably, I don't know what's on this one, but anyway, it's only junk. It's got cobwebs all over it. I don't think it's much good. So what will happen is your tape's like this. It's had a couple of loops around the head here, and if they don't get wound back in, everything's not too bad there. But as soon as this gets ejected, crunch, your lid shuts and crunches up your tape, and usually as that comes out, it'll be hanging on every bloody thing like that. And it won't quite make it to fully unloaded, and that's what chews the tape in these. The most common cause is on eject, and even the mechanical gears can crack and fail. The pulleys on the motors can fail. A lot of the later ones don't actually have a real motor. It's just a belt off the capstan motor, so if there's something wrong with that belt, the pulley on the capstan motor, sometimes even the capstan motor, but it's usually to do with the idler. I've had plastic ones that have just slightly bent, and they'll just scrape on the metal a bit, and it can be months before you can get the buggers to do it, but occasionally they'll chew a tape. And some of the Daewoo mechs and stuff that NEC used were like that, and they were real hard to find at first, but the plastic would just warp slightly, and once out of every 20-30 users it would chew a tape on eject. So that's one of the main problems you'll get with these. Like I say, these particular Sharp machines, it was mainly the sensor lamp and the idler tyre. Eventually the whole belt kit needs doing in these. These old ones have got a great big flat belt. For the capstan motor, this is, because it's an old school video, the capstan motor is this round, simple DC motor here, and it goes to a big flywheel. That belt's pretty well stuck to the capstan in this one, because it wouldn't have been used for a long time. Surprisingly it's not. Yeah, it's leaving a great big trail of, and there it goes. But normally these just get a bit, they don't get to this bad a stage. They just start slipping. You'll start looking at the machine and realise, and normally if you had to replace any of the idler, you could buy as a separate bit, just the tyre. But any of these other belts you had to buy them as a kit. So if you found any of them, this is the loading motor, as in deck. This is another motor, so this is to load the actual mechanism. This controls the tape guides in this one. In later machines they had a motor. It'll do everything. It'll run the mode cam gear here, and that will run the eject. There'll be a lever somewhere from the eject mechanism, whatever will come into this, and that style of thing, or there'll be a separate pulley off that motor. So again, that's another way they reduce things. This has got a couple of, I forget what they even are really. They're some sort of reel sensors there. I think this used, let's have a look. This is just a tape. Oh no, actually it's got a sensor there. So this is a tape counter belt. This came across to a pulley and then went off to a tape counter on the front of the machine. This has actually got a Hall effect sensor on it. Little darker part there, which the second belt goes around, is actually magnetic. So if this stops working, the machine will actually stop running during play. It'll go, well, it's about to chew a tape, and probably that stage it's too late anyway. But if that stops rotating because of this stopping rotating, can be just do a slipping belt off, and it was a common problem for machine. All seems to be working fine, but it would just shut off, go back to stop. It was just because this belt that feeds that Hall sensor would slip, and the Hall sensor would stop rotating enough, and the machine go, oh, I'm chewing a tape, and turn off. A lot of the later ones just had an optical sensor under each of these. I'm trying to remember what these machines have some sort of coil under them, I think. And it's going to take a bit of racking my brains to remember what they actually were for. Or was that a solenoid or something? Was it a brake? I can't actually remember now. But a lot of machines you'll find, if they're intermittently stopping during play, you pull the reel off. There'll be a little round black thing in there with like two little windows in it. I'll see if I can find one after to show you. And that's like a photodiode and LED in one package. It shines up. The underside of this, instead of having these teeth, will have like a black and silver patches on it, so like little foil patches, which alternately break and make the light, so it knows something's rotating. Because if that signal coming back from the photodiode switches on, switches off, switches on, switches off, like a sort of square wave, it knows there's rotation. If it stops and is either on or off for too long, it'll shut the machine down. Often they've just got a bit of grease or tape oxide or dust or whatever in there, and you just clean them off. I have even had machines where these reels, there's silver foil on them's gone dark or fallen off or something. You've actually had to change the reel, but pretty rare. But the sensors would from time to time play up. Oops, there's a couple of plastic washers there that need to go back on. Occasionally you'd have to, if you've got noisy rewind and stuff, you'd actually have to take these off and lubricate the shaft there. Pretty rare you'd be taking reels out of machines. Generally these reels themselves don't fail or need replacing. But I don't think I can worry about that washer. But occasionally, yeah, you'd, if it was slow to rewind, fast forward, or noisy or whatever it could be, these needed a lubrication. Yes, I'm not quite sure what those bits under there are. I'd have to look at the manual for one of these again, probably. So most of these later machines, the capstan motor is not a little DC motor, it's a proper servo motor. This sort of flywheel part will have a circuit board under it. It's very similar to this head drum. You have a flat circuit board going in under the motor itself, and a bunch of coils which are sequentially switched by the chip that then spin the magnets around this big lump of aluminium will sort of be gone and just be a metal plate. So with the later capstan motors, with the circuit board and the servos type thing, they'd have a shaft coming up out of them, and about all that would go wrong was often the bearings would fail in them, which is usually fairly obvious. They're not spinning too well and working too well, they're noisy, etc. The other thing that would go wrong is with power supply faults, you'd get the chip blown on the board, which could be quite an expensive repair in some, because you had to buy a whole new capstan motor. Some were up around $140 and stuff. And the same with the bearings. If the bearings went, you had to buy a whole new capstan motor, so that was the death of many machines. It just wasn't worth spending the money on them when they were quite old. So that was a common thing. I did manage to find some of the Sharps, the VCA series. You could actually swap the bearings out of one of the, I'm not sure if it was an older Sharp or might have been a Samsung machine or something, but you could actually just swap the bearings and do an economical repair for the customer with a used bearing, one that never failed in those motors. So you just tell them, look, I can do a cheap fix for you, get it going again, and if it goes again, yeah, well, you can chuck it out, but they seem to last for years, better than the original ones. And yeah, the other main part of these decks, we've covered that. Obviously just got the capstan sets of speed, is the actual mechanical side of the deck. So this machine, being an old one, has a little switch here to detect that the tape's gone in. So that means that it's loaded up. As soon as that got pressed in, this other motor here would start up. I guess you'd call it the mode motor. Yeah, September of 1983, there you go, it was an 83 machine. This little motor will get powered up. That runs this belt into a couple of gears, and they run what is known as the master cam. So what I can do is probably remove this, so we can actually have a look at how all that works, because most of these mechanisms, if you need to fault find them with mechanical issues, you actually remove the mode motor. Looks like there's a second screw, because then you can wind them through by hand. There's no chance of breaking things, and you can basically control the machine. Okay, so that's loose. Yeah, so now I don't know how good this mechanism is going to operate since it's so rusty. And another part, which is, this is mounted quite different to most newer machines, is the mode switch. So the machine needs feedback as it goes through its different modes or different mechanical positions. It needs this switch to keep track of where it's at. So is it in rewind, is it fast forward, is it in play laced up, play unlaced, etc. So this is just like a multi-contact switch. A lot of the later machines, they're rotary. This one, I guess I could actually, I think we just undo this screw, pull it out. This is a linear one, or a slide switch, which didn't last very long in VCRs, only in the early ones, I think. Some of the later may have used it, but yeah, basically doesn't seem to want to. What's holding that? Oh, it's actually fitted into a little slot there. I'll probably have to take the bracket off that it's mounted on. But basically this has a, yeah, I think I'm going to have to take that bracket off even to demonstrate it. And they've put yeah, that'll come off. Put Loctite on it. Looks like you've got to move the mode switch to get the bracket off. Anyway, yes, that is tight. Okay, if I get that off, that still doesn't want to come out. But anyway, so this is a linear type sliding switch. It'd be nice if that bracket would go away. How do I do it? Does not want to let go. There it is. Made in Japan. So it's just multiple wires soldered to all these different contacts. And that might even, is it the sensor? Oh no, it's the other switch. This other switch for the cassette in, looks like the white wires of that come in here and get connected up via this switch. That just slides from side to side. And these contacts will get dirty in these things. Yes, there's 4 pins. You'd actually have to undersolder these 4 pins, pop it off the circuit board. Actually, not these ones you might not have to. You might be able to get the top cover. God, so long since I've done one. Yeah, this the actual top cover comes off by the look of it. If only I had a knife. I think you've got to cut these little tabs off, and we can get inside that. But anyway, it's just a few circuit board tracks with some cross contacts that slide between them, and if they get dirty, there's a bit of grease in there. If they get dirty, the machine may do weird stuff because it's not getting told when it's in particular modes properly. It's getting some sort of noise through there or not the right signals, and it'll tend to shut off and go back to stop mode. But that switch basically tracks what's going on mechanically. So this, when the loading mode is activated, we start winding this cam gear, which I'm now doing by hand, and you'll see this in this machine, because it's quite simple. It basically controls some slide arms here. It controls the gears that run these tape guides. So if we go into play, we'll see the tape guides come up. We've also got this tension arm come across. I've now hit the end of the run, so the mode switch should tell it if these, like jam as well, can be another thing, they go too far and don't stop when they should, like when they're laced up, as we call it, when the tape's up around the heads. That can be another sign the mode switch is playing up. It may even break the master cam or something. If I wind that back, in some machines this will keep winding and will actually load the cassette in and out as well, especially like I've already done a video on the G mechanism Panasonic. If you wind it through the modes, it does everything from loading the tape in, getting it in place, then it laces up, or it has like a half loading arm that puts the tape up against the control head, and then further arms to do everything else, like the full lace up. And it basically also, this will have modes. It's not, this is play mode basically, so we've got, this is usually the end mode, everything's laced up. We've got a tension arm. This is what is known as another important part of the video, the back tension. Might have to break this up into separate bits eventually, but you'll see you've got this sprung arm here. Now when the tape's in, this will come out. This is sitting under the cassette, so this will follow the tape out. So the tape's on the side of it, and it will pull a loop of tape around this wheel here. And it's actually very important. It's not just to get a bit of tape up against this erase head or anything, which has now swung in, because normally I think the guides, probably doesn't matter, it just knocks it out of the way and back again, I think. But we've got our erase head here, but we need tension all the way around this tape. The pinch roller is one end that's pulling on it, and we want it hard up against all the heads. Without this, it'll be quite floppy in there, even though it's being pulled through, because this reel just runs freely. It doesn't have a lot of tension on it, and so it can be hard for the heads to read it and stuff. So what we have is this lever that pulls back, and that's attached to this brake band, which is just a bit of felt stuck to a bit of copper by the look of it in this case. Sometimes it's plastic, and that actually pulls back. The actual mode thing in this has got a little pin that controls where that sits, but you can also adjust this screw here to set the back tension. This piece will slide back and forwards, and that'll put varying amounts of tension on the tape. They did make a back tension tape you could buy, which will actually have like readings inside the cassette on the reels, or you could buy ones that you could put on the reels, and they'd give you a reading of the sort of torque, I guess, or the tension. A lot of the time I didn't worry about it. I could pretty much do them just by feel. I could actually get my finger on there and how somewhere around the heads here, and you get an idea of how it was. If the tape starts squealing as it's going around the head and dragging, that can be too much tension. You just push back on this lever and you'll see it actually, it'll start running again fine. So you need to back off the tension, or there's something wrong here. Another common thing, especially in the National Panasonic videos, was the actual felt would fall off these. I think there are other brands that did it as well, and it'd fall away, and you'd have not enough tension, so you'd often get a bad picture or something. It wouldn't track properly, something like that. And there'd be absolutely the tape, if you pressed on it, would be as loose as. But you'd usually, as soon as you open the machine, you'd see the felt pad had fallen off, and you could either just glue it back on or replace the whole tension pad or band. But there is a little screw setting here, technically, to get the headwear perfect and not excessive. You really were meant to set it to whatever the standards that tell you in the service manual for that machine. But like I say, it's very rare you ever had to do it. With the ones that the felt fell off, the other reason to use just to glue it back on was you could mark exactly where the thing sat. Often they got this Loctite or whatever, which will break and leave it and stay there, so that'll be the marking. And it was easier just to glue the old one back on, and it should be the same tension once the pad was back on it. as originally set. That way you don't need to fiddle with anything, you don't need to check the back tension. If you put a new one in, you've got to set it all again, because the length could be slightly different or whatever, the felt's probably newer and all the rest. So generally I tended to just do it by hand, just double check. Most of the time you didn't have to actually set the tension, you just felt it to see, because if there's a bit of muck on the drum, if the tape's got oil on it or something, all sorts of different things will cause tension issues. Sometimes on these tape guides, the little plastic bit, which you can sort of hear it rattling there, that'll rotate. Sometimes they would seize, and that'll cause excessive tension and stuff. But generally you didn't need to set the back tension. Back to factory specs on most of these. Now the other thing, I don't know if I can see it on this master cam doesn't do an awful lot, but it should also do things like this lever. If you watch these levers here, they'll move across, and the actual pinch roller, this whole long lever is actually going all the way up here to the pinch roller. So when we get in the play mode, pinch roller comes across and presses against the capstan. Usually that's the very last action it does, is push that in, and when we come back the pinch roller goes right back out, so the tape can be ejected without getting caught or anything. Because this machine's got its own fast forward rewind motor and idler and stuff, it doesn't need this to do any of that. In many machines these levers will actually control where the idler can go. There may be other little, like there's little brake pads. There's a brake pad there. Doesn't have one on this side on this one, but they've got other braking pads so that when you come out of rewind fast forward, they need to flick across and stop the reel spinning. So I've got just here, there's a spring and a little metal lever here which will press against the reel, and this one it's probably going to hold. Does it hold until, yeah, and then that comes off once we're in. So it's probably going to be dragging tape out on this side, not so much that side. It may be to control to stop this reel turning until we're in full play mode and the pinch roller engages. So that's that. As this lever moves across, that brake pad comes off while the tension pad comes on. And when we go back, this is actually, doesn't have a lot of tension, but just enough to stop it turning easily. So I don't know with, yeah, when we go to rewind fast forward, no, this doesn't actually let it off. So maybe that pad does sit there, just puts a little bit of tension on that. A lot of machines, when you go to rewind fast forward, it'll rotate the cam a bit, just so that there'll be a pad on each side, and they'll disconnect off or move back off the reel, so allow them to run freely and fast forward and rewind. Doesn't look like this machine does it. And like I say, there's the mode switch monitors all that and tells the microprocessor what's happening, what mode it's in, that it needs to stop because it's laced up basically, so it knows when it's got to the laced up position and the pinch roller's in. Some machines will let the pinch roller off. Usually that'll back off when you go into vision search, so that is fast forward rewind with a picture on the screen. It'll actually, I think the pinch roller disengages and then it just uses the reels, and the heads will keep spinning to try and give you an image. Often it didn't work that well, but it gave you some idea of what you're going through. So like an ad break, you see it on screen, lots of lines and rubbish and bad tracking, but you could at least see where you're at and see when the program came back on that you'd recorded. So that sort of covers the most of that. The cam gears themselves, because they've got these slots in them which have metal pins sitting in them, some on top, some below. They often need a bit of grease putting back in them. These Sharp ones used to wear out eventually, not so much in these 300 series, I don't think they were quite good, but in the 400, 500, maybe 600 series they would wear out. These grooves would get all full of flakes of plastic and get all rough, so you'd have to change the gear. Sometimes you'll find teeth broken off them or something if someone's really forced it or jammed it, if a tape got stuck and they force something. The other thing is these two pieces here, we might even remove this plate here, which is how you get your cam gear out. You'll need both circlips. Oops, get that circlip out of there, might as well keep that. Take that plate off. So you've got, yeah, so this plastic bit here has a metal pin in it, which follows the groove in the cam gear, and this other tooth part of it, as the cam gear swings that around in that groove, you can see it like winds its way out and in. So this will move from inner to outer, and as it does that you get this motion of these teeth, which then run our tape guides. So if I rotate those gears, you can see the tape guides going up around the head and back. So normally this bit I don't think we ever had trouble with. Like I say, these grooves can wear out on these. If you're ever servicing one of these machines, you usually check the grease in it and often add a bit more. Same possibly with the teeth on these. The thing that did break in these is these have another spring up inside them, and they will break. They're on a plastic, I think it's a metal pin one end and a plastic the other, or it might be both metal, but these will crack and stuff. Sometimes the teeth will get broken on these, usually only if someone forces it, but they can break of their own accord. The springs inside these, so you have to take that circlip off. Well, I guess I can probably even show you, because there's not much point worrying about this machine too much. And there's the other thing, of course, with these is alignment is important. Oops, I have to push on that. I thought that hole there lined with something, but with the cam gears they'll often have a hole in them somewhere. It's probably on the other side in this one, and you'd have to make sure you got that in the right spot. You've got to make sure that all these pins fall into the right slots. So you're generally in the manual to tell you that you have to mount it in a certain, get everything in a certain position, like the stop position or the play position, and then the gear should drop in with the hole, often a hole on the outer would line with some hole in the chassis or something. And same with these two gears, generally need to be aligned. So if I pull that up, yeah, we've got the pin there, that used to break I think, and then it's onto this metal piece here, so we can still get that one to turn, but the other one won't. So that's the tape guide going back and forwards there, and this is the bit that controls it, and those springs pulling hard against that pin. I think the plastic here would crack and the pin would go sideways or fall out or something. That was quite a, not that common a problem in these, but it would be a problem. So when that's like that, you'll find that as our arms go out, one of them won't move at all, or it'll kind of make a half effort. When they come up to the end here, they should be really, that you're pressing against that spring in there, so they would spring, you know, push on them, be very hard to push back, and it would spring straight back into place. If you get one and you push on it and it just sits there, you know something like that's broken somewhere in the gearing of that. Generally the actual arms and these end bits didn't fail. Like I say, occasionally they would freeze up these plastic bits or split or something. You know, these actually, tape guides have these little slots in the ends of them, because these are adjustable. There's a little tiny Allen key grub screw in each one, which you have to undo and just loosen off, and then these become free, and you can put a screwdriver. There was actually a proper tool that was, you know, like a screwdriver with a central bit missing to get in both sides at once, but often I just used a flat blade screwdriver. Once they were loose they turned alright, and these actually set the height of the tape across the video heads. So if you've got like lines at the top or bottom, it was often these were out, and generally once they were set they shouldn't get out, but they could be adjusted. They also affected the tracking of stuff as it came across the audio control head. The audio control head itself actually has, it sits on this funny sort of sprung base. There's a spring on one screw, there's another screw there. This one looks like it's got a grub screw as well, but you could actually get in and adjust this if the tracking was out. Often you just went by the audio to make sure the audio sounded the best, would get the tracking head in alignment as well, so that can be adjusted. Again, pretty rare you would need to. Pinch rollers being rubber certainly needed a clean. These capstans, I can't believe how clean this one is, because normally they were so bad in these machines you'd actually have to get a bit of scourer pad, because I think they're stainless steel anyway, they're very hard metal, and you get all this oxide on them, and the only way to get it off in any decent amount of time is actually, I used to get a scourer pad, just that green kitchen scourer stuff, and actually use that on them. Pinch roller, you just use methylated spirits or something on a cotton bud. These would eventually wear out. Pretty rare with most of them that they'd fail. The bearings sometimes would fail in them, they're just sitting on a shaft with a single screw here, and it's just a bearing down inside that. just at one bearing. That bearing just sits on this metal shaft, and the screw on the other side of the bearing, and they just rotate. They could get pitted on the surface. This one's almost as good as new, really, if I gave that a clean. They tend to corrode a bit, these aluminium ones, for some reason. I think it's the rubber, which is one of the things that fails. Bearings normally didn't fail, but some of the new machines, you'd find them and they would wobble around on the shaft because the bearing had just self-destructed. I did have the odd rare case of these. The rubber goes oily in them, and you won't even notice it. Sometimes there's maybe something they're a bit corroded on the aluminium, and there's little blobs of oily looking stuff on top. But if they get bad enough, they'll actually put oil on the tape. So you'll play a tape and it'll be perfect, but as soon as you rewind that same tape, especially in like vision search rewind, it'll scrape up on the heads, it'll get really high tension and won't drag across properly. It may well stop the machine, it may dirty the heads, and so that's a rare but occasional fault with the pinch roller. I never used to replace them as a service item. It was just a waste of money for the customer with most of them because it didn't cause problems. A lot of people seem to think that's why they chew tapes, but I don't think I've ever had a chewing tape due to an idler, to a pinch roller. But an idler, definitely, you'd normally just give these a spin, and they should just keep going like that. If the bearing's good, if they slow down straight away, if they feel like they do wobble side to side slightly, but if there's much play there, the bearings probably had it. Pretty rare. We've got another sort of tension wheel here. Again, you just check that it spins nicely. I think that one's fixed, yeah. And yeah, this machine has another sort of spinning wheel here, which is usually they have something here which is what the tension arm pulls against. Again, very rare any of that sort of stuff plays up. About the only other major sort of component here is the actual head drum itself. Can actually have a look at removing the heads, because these heads do play up. They do wear out over time. They do break easily is another big problem with these. One of the big tricks is cleaning the heads. And usually when these are dirty, all you'll get is just a snowy picture. You might get a little bit of image under there. But these you've got to be very careful with these. I mean, one thing is you don't want to put your fingers all over this aluminium because the fingerprint will eat in. So if you do touch it like I just did then, you want to wipe that off. Normally when you service the machine, you clean all this aluminium. So the whole head surface, this one's got corrosion and stuff, I doubt it's going to come off completely, so sometimes they will still work alright, like with the little patches of corrosion on them. But this one's basically scrap metal at this stage. I think it's got pretty bad corrosion there. But you would clean this whole surface. You'd clean this lower drum, just a bit above this little edge here where it's a bit lower diameter. That's where the tape runs. So we'd clean all of that off. If you did touch it with your fingers, usually best to clean all of it, especially when you put a new set of heads in, just in case the customer looks at the machine later and sees your fingerprints all eaten into the surface. Doesn't look very good. Not that it affects it if it's on this top part, doesn't worry anything. But on the bits that touch the tape, you don't want anything that can cause friction or anything, or maybe damage the tape. And you can get away with just these normal cotton buds that you get at the supermarket. Just make sure the cotton's pretty tight, there's no loose bits. And basically what you have to do, normally you'd have it just flatten the machine and work from above, but just so you can see what's going on. I might have to do a close-up of this after, but you can see where these wires go in, and there's a couple of holes. Usually the dead giveaway, that's where the head sits below. It's this little slot, little dark bit you can see as I move it around. And that is just a hole in the aluminium, and then inside that hole itself is this little flat bit of ferrite, and you can just see some copper wire in there wrapped around it. So it's like a little flat edge sticking out of that hole. Extremely thin and fragile. If you rub this up and down, you'll just break it off as quick as, like, it's very fragile. So you've got to follow this line between the rotating and fixed parts, and you want to basically press against them. And you can either move the cotton bud side to side or rotate the heads across the cotton bud, just with a small amount of pressure, being super careful that none of the threads of the cotton bud get torn off because the edges of the head are kind of sharp. And we go side to side. No up and down motion at all. That's why we follow that arc of that line, and you often see a bit of brown stuff come off, which is tape oxide, especially if it is actually faulty and dirty. any sort of, you should never use tapes that have been chewed, like this one I've just damaged, because when this gets chewed up in here, I mean, you've got the crunched up bits of tape, which can lead to the oxide coming off. Normally doesn't though, but much far worse than that is, I mean, just me touching this will leave greasy fingerprints on it, which can clog the heads up. But if it's been in the machine, wrapped around the guides and stuff, it's bound to have picked up actual grease. And as soon as you play that bit again, not only will it have dropouts and stuff because all this screwed up tape, all the bends in it and stuff, you also get a deposit of grease off it, and that'll get on the heads, and usually you'll get an instant dirty heads. Often it'll have trouble dragging over the drum as well, and often leave a bit of grease there. So generally once the tape's chewed, it's best to either cut that section out or chuck the tape out altogether. If it's just like a home recording, you just turf it. You don't want the customer putting that back in their machine. I often just used to use them as test tapes and avoid the bit that was chewed up, because I would, when you've got a tape being used in faulty machines all the time, it gets chewed quite a few times, and eventually you end up with the whole length of the tape is pretty chewed, so you chuck it away. But they were good for test tapes, as long as you remember not to like vision search over the bad bit or play it. So you'd sort of start at the end of the tape and just keep working through and using small sections until they got damaged. But for anyone else, as soon as it hits that, there was always a problem with like rental tapes. If someone had chewed it and just took it back to the store, didn't say anything, then the next person that used the tape would get dirty heads off it. Sometimes just dropouts and a crappy bit of the movie, but most of the time you'd end up with dirty heads, and so then you've got a customer who's not happy with the video store because the tape clogged their heads up, which is quite a common thing. We could also look, while I'm at it, I can look at, since it's such a common job in these, is actually replacing the idler. Now most of these Sharp machines are very simple to change the belts in. I'll do some later videos on that, no doubt. I've got a few machines that need belt kits. With these you would remove this metal bit and then try and use some side cutters or something to just unhook that spring. Put that to one side. And those screws actually undid the, God, look at the rust on that, undid the reel motor. Normally you'd give that pulley a clean. God, this thing's actually seized up, not surprising given the amount of rust on it. It'll probably go again with a bit of lubrication. Knowing how solid these motors are, I don't think I ever had a real motor fail in one of these. I may have, but it was very rare. And see, then we can pull this whole idler assembly, just pulls out. Most machines are a similar setup. This actually looks like it's had a new idler tyre in it. Yeah, that's like new almost. This machine may have been well serviced. Looks like someone's replaced the lamp in it at some stage as well. It certainly wouldn't be on its original one anymore, but that idler tyre's still got the surface like they have when they're new. So you pull this assembly out, there's like a little clutch, there's a sprung bit here, and then this bottom bit, if I pull it out, there's actually a felt clutch under there. Generally these plastic bits didn't fail, it was just the rubber bit. Then you've sort of got to get your fingernail or a screwdriver or something. I forget exactly how I used to do them even. Often you'd use a little precision flat blade screwdriver or something. I think that's how we used to do it. Hook that under it, and your tyre just peels off. And once you get a new one, you just put it under one side and you can just pull it on with your fingers, making sure it's all gone in. There's no twists in it or anything where it's caught on the edge of it. And then it's just a reverse process. Sit that back in place, pop your motor back through the hole, and then screw this bit back in, reattach the spring, and you've got a new idler in the machine. So it's pretty straightforward. I might even put a screw back in that motor so it's not swinging around everywhere. I think these have multiple holes in them, but you just got to line the screw holes up and away you go. Occasionally you'd get these drum motors would fail, no head spin up. Usually if the heads didn't spin, it wasn't any of the signals coming in, they just come from the microprocessor or whatever. It would be this chip. Most likely has failed. Sometimes it may be some other faults, but it'd normally be this chip that has failed. Sometimes it could be other faults, and you just change that whole circuit board. This other part comes off. There's a couple of grub screws. An important thing with these is you often had these actually have magnets in them. or a ring magnet, and they actually have to go back in the same way you got them off. So often mark the shaft. You get your Sharpie or something and you'd mark the shaft across. So the shaft and the outer part, this bit slips off that central silver bit. So you knew where the two were originally located, because if you get these in the wrong way, it can affect the head switching, because the two heads have to be switched in the right sequence. I actually had one machine once that had a weird problem with half the picture missing or something, and it was a second-hand one I bought, I think, and it turned out that some mongrel had actually taken the magnet. It was off a more modern motor than this, but they'd taken the magnet assembly off and put it back in 180 degrees out. So it's causing a weird problem, which of course you'd normally never see, because once they're set in the factory they stay that way, but someone had changed it, so you get a few odd things like that. And these heads do have to be switched a certain way. There were adjustments in these machines. You could go through with an oscilloscope and set the head switching point, because basically this signal coming back out of each head through the rotary coil or rotary transformer, the machine had to display each bit in the right order, and part of that's to do with the motor magnet there, the motor being synchronized. I'm not sure if that feeds something back to the head switching signal. It's probably the Hall effect sensors and that or something are actually feeding back speed and head position, whether it's head A or B or whatever they call them, to the microprocessor or some other chip, so it knows what it's doing. I have, very rarely you would get the rotary transformer failing these. What you've got to do, they're basically just a coil. So you can go back to these connectors here. Probably could almost work out what they are. If you've got like a half sort of picture, looks like there's just snow or something on one half of the picture, something along those lines, large part of the picture missing. Can be a faulty head, can also be one head broken off. But if that's not the case, it can be this rotary transformer, and you can actually just test these on continuity on your multimeter. And looking at this, I see what looks like an earth line. These two join together, and then there's 2 and 2. This other stuff I think goes to that heater, and I don't know what. There's a couple other wires going up in there. Might have to look see what they are. There's a good chance it's obviously an earth on the board here. And I don't know that they're connected to earth. Doesn't look like they are. So there's probably a coil maybe there. No. Maybe that one's open circuit. I would have thought there'd be a coil each side, but yeah, so it could be possible this one is faulty, or it could be something I'm measuring the wrong thing, but you'll just get a beep across it. Pretty sure that was the rotary transformer on these. I think I only have had to replace one lower drum in one of these. And what we can also do is we need to unsolder these to remove the head, but we also need to unsolder them to test the head and the rotary transformer. So again, if you've got some sort of like half picture, really bad picture with some like nice colour, reasonable picture, but the other half's all snow or grain or whatever. And again, these two wires go to this side, so it looks like a yellow is a common on each head. We can measure from that to that wire. We should get a short circuit if the head isn't broken. If I busted that head off, it may still measure okay. It might just be hanging there by the wires, but usually it'll break the wires as well and you'll get an open circuit. Being very fine wire, as long as I'll get one of these off the head drum itself, so I'm not just measuring the aluminium. Being very fine wires, they can go open circuit. Something could corrode them, or vibration, whatever could get to them. And of course, where these wires went, we've got yellow and red to match, so these also tell you which way around this head. If we take this head off, it can go around 180 degrees, but we've got a brown yellow one side, red yellow the other side. Again, you can get your marker pen and just, mark whatever. Just to remind you, a lot of the later ones, there's just a circuit board on this bit as well, and you just solder a couple of pins that go down into that rotary transformer. But to check the transformer, we should just get a short circuit there, and a short circuit there. It's pretty unlikely they'll short the chassis or anything, they'll just go open circuit normally. It's about all that can go wrong with them. It's super fine sort of wire. To get the heads off, usually you've got two screws, much like this. And one of the reasons they had the screws on that other cover, I think it's just on these later ones to stop these wires. It probably might get a bit out of balance or something, I guess, if they start sticking up. And we have this old tool, which is a head remover. Basically just the central part that pushes down on the inner spindle there, or shaft. And we've got two little threaded bits which go into where the screw holes are on this one. Some heads just have the hole, never have any screws in them. So we screw the outer bits in so that they're gripping the head, or the upper drum. Get our wires out of the way, and then when we screw the centre down, this can slide side to side, etc. Those can move in and out to suit any heads wherever the holes are located. And we just push down, and this is just coming off nice and easy. Sometimes you've got to heat these up with a hairdryer, and you simply, that central bit pushing down on that with the screws pulling up, just pops your head off. And that is how you would replace a video head. Like I say, the later ones, there's usually pins coming up into a circuit board. You've got to unsolder with a solder sucker, make sure all the pins are loose. You can flick them with a screwdriver or something, because otherwise if you pull the head upwards you'll rip the connections off the rotary transformer. And underneath here we can see the actual heads themselves. Again, I might have to do a close-up of that, but these two screwed on bits on the aluminium drum here, and they come down to little brass pieces, two tiny little wires going through the hole in that brass piece, and then at the very end here a tiny thin bit of ferrite, probably not much thicker than a hair to be honest, but maybe a little bit more, with a coil of wire around it. The coil's soldered to this little circuit board bit on the screw, on the brass, and then that goes to bigger wires. But in a later machine it will just go straight up on a little plastic bit and be soldered to a circuit board. So that's that bit. When you order new heads for a video, you just get a package. I don't even have a new one anymore. It used to come in a styrofoam package, and that's an upper drum. Usually they have a type number on them. This one doesn't. I don't think that EBX21's got anything to do with it. A lot of the Panasonic ones and stuff, I think, have it in the circuit board. It'll give you a part number. This has got a part number down here in the lower drum, just for that circuit board, FO501GE, which is typical Sharp. It's got TDK on it, so I don't know if that is anything to do with TDK. Something about 12 volts. So this is our upper. You can actually see the rotary transformer now, and it's this brass bit's just to hold the head, and probably a bit of flywheel action. This should normally spin really freely. This one's not so good. Somewhere in here, it sounds like it's at the motor end, we've got a bit of friction, but normally if you spin ahead it should just keep spinning real easily. And then we've got these two black bits which are moving against each other. They're just ferrite, and there's a coil of wire inside those. We'll pull that to bits later and have a look. And on the lower one, a couple of wires, probably the ends of the actual very fine wires that are in there, come down. Again, yeah, we've got our yellow red, yellow brown pair. They come down to these tracks, and I was right. That outer pair is one set, and the inner pair that I measured before are the other set, so we might actually have an open lower drum on this machine. But to be fair, it doesn't look like it's had any corrosion in here. Yeah, that's stuffed. So maybe that's why the machine's not rotating too well, but this would actually only be given half a picture or so, because we've got an open circuit. So this might be a good chance to actually have a look and see what's going on. If you want to take the whole drum assembly out, it's only 3 screws. Normally you wouldn't take it out when you're servicing them or whatever, but if you have to replace it, or you just want to throw it in the scrap metal bin because it's the end of life of one of these. Actually, it's not going to come out without taking the motor off by the look of it. This one's got Allen keys, so I'll have to find my set of fine Allen keys, so I'll have to take this rotary bit off and the board, and then the whole thing comes out. Looks like this little plug's holding it as well, or at least the little strap around it is. And then we can actually have a look at what a faulty drum looks like. I don't know whether we'll see much, or lower drum, and the rotary transformer. I'll just see if I can find my Allen keys. These are a little set they used to make for doing VCRs. I hope they're still all in there. That one's going to be close, but I don't know if that's big enough. probably too big, believe it or not. Sometimes they have a bit of Loctite or something in them. So hopefully one of these fits. This one looks like it's had a bit of use. Most of these will just have 2 screws in them. Very tight. Oh, it doesn't help if you go the wrong way either. I don't need to go anti-clockwise. But still broke the actual Loctite, which is good. Probably doesn't need much of a turn, but I'll just do it a little bit, couple of turns. That should be well and truly out. But yeah, most of these are all just later ones. They're just steel and actually comes off quite easy. So that's got like a rotary magnet in here that's holding my, but it must be, I assume, 2-pole magnet, because the machine seems to know which way around. Maybe in this older machine it's not, but I know in later ones they're definitely picky about it. And I think we've got to take some of these screws out. I don't know if it's the ones with the Loctite or the ones without the Loctite. They didn't make it so obvious in this machine. One set probably holds the motor together and the other set holds it to the... Alright, I'll take like a set of 3 out and hopefully they release it, otherwise it'll be the other 3. Been so long since I've done one that I can't remember which set it is. I probably knew once upon a time. Well, I've still managed to pick the right one, so that's pretty good. After probably 20 years since I touched one of these machines. So that's our circuit board. You can see little Hall effect sensors, these little 4-pin black things. So this isn't actually the flat coils, this is built up on a bit of metal. Most of the later ones, they decided they could get rid of all this iron and stuff. And I think they're just literally copper coils on the actual circuit board. So again, another saving, because this soft iron, high reluctance, or whatever they call it, high reactance, whatever it is, that was quite expensive stuff, I believe. And now we've managed to get that right off the chassis, so we've got our lower drum out. Get rid of that old belt. And there's some sort of plastic thing between the motor, and if I get the deck to one side, if I keep removing screws, or do I just take that shaft off? Actually, I don't think I need to do that other connection. There's another little coil-like thing in there. I'm not sure what they actually did. You can take this sort of base bit off and get the lower drum as a separate piece. So if you had to order a new lower drum, you'd actually have to pull that to bits. That wouldn't come with this bracket part. Normally, if you were fixing a machine, that would have been so expensive back in the day, it'd be in a second-hand one or something anyway, probably, so you'd just actually pinch, that comes off as well. You'd just pinch this whole piece out of another machine, second-hand one, that was ruined for some other reason, and just swap the lot over. I think most of these Sharps are all compatible, but obviously if you have more heads, you'll find there's more connections. Don't think any of this Sharp 300 series were hi-fi or long play. Actually, they might have made a long play version, so that would have had another couple of connections and more transformers, so all this would be different. You'd have to have a 4-head type lower drum. I think if I take this brass bit off, we might be able to just pull the whole lot out from there. Don't know if that's the same size Allen key as the other ones. Looks like it might be. Maybe not. Is that going to go in there? Surely that didn't make it a different size again, but I know what manufacturers are like. That one seems to fit, only just so. Not sure that's going in properly. Doesn't feel like it is. That's about the only other size I've got, or is that? Oh, is that? No, they're about the same, I think. I can't even see the difference between these Allen keys, but some seem to fit and some don't. I'm pretty sure I'm missing a couple of very small ones somewhere. Jeez, dude. I mean, look at the difference in size. 2.4, 1.5, 0.9, 0.71, or is that 0.7, 1.27, 1.6, 2 and 3, which they're in the wrong pocket, obviously. So we're talking like 0.2 of a millimetre difference on some of these pretty sure that's the one that's meant to go in there, but it doesn't seem to want to fit in. Maybe I am missing one somewhere. If I could just... Sometimes you just have to tap these in, there's a bit of Loctite or something in the way. There's not much point trying to turn it if you can't get the key right in, it'll just chew out the end or chew the key. That does not really want to go in there, which is highly annoying. That does look like there's something in there, because it'd be nice to get this apart. Otherwise I might have to get the grinder and cut it off. It's obviously stuffed anyway, because if we've got an open circuit coil in it, it's not going to be useful again. So I'm glad I checked that. I probably would have kept this part otherwise. I think I'm just chewing it out, or chewing the Allen key, one or the other. Yeah, looks like we might have to do it the hard way, because yeah, I'm pretty sure if that brass bit comes off, I'll just double check if I've got any keys anywhere, but I think they're only the very tiny ones. Can't even see them. That's a shame. I'm surprised it isn't managing to bite into it. It should turn it. Okay, that didn't feel too good, but I think it gave way. Maybe just that end of the key's a bit worn or something. Using the other end, it actually holds in there well, so that's good news. So if we get that off, I'm not surprised they've had quite a bit of use, those things. I think we should be able to... It doesn't feel like it wants to go, though. Haven't got much to lose with this, so I reckon this is just so seized up from age. Ah, that's right, the coils used to come loose in these. Might need a bit of lubricant on that. Normally you'd have to be super careful with these. Put some RP7 down both sides of that hole, and that should get to both sides of that bearing, or there may be two bearings in these, I can't remember, but oh, something is very not happy there. Put a bit more on there. The bearing's almost coming out, I think, as I'm knocking that down. These normally, I think from memory, would slide out no problem, but yeah, given the age of this and the condition as it's been in, I think we'll just have to... But what would happen is these copper wire coils, there's two of them, sort of concentric ones, they were actually glued into the ferrite bits, into little slots in them. And now seeing this again, I remember that the glue used to dry up and go brittle, so the wires would fall off and they could actually like scrape. And of course, being very fine wires, if they're scraping against the other coils or ferrites, they could actually wear themselves through. So that's what that would make them actually go open circuit. So it's been a very long time since I've seen that, but that from memory is what happened with them. This has got two bearings in here, I think, because I've knocked it out of one. Oh, there we go. So that's our concentric coils in the bottom one, and in the top one. So these are still intact, so that's surprising, because this is actually, the coil is just lifting out of the, it's just falling out. There used to be some sort of brown glue in there, there's virtually no sign of it. There's a little bit of glue still left there, but I think that almost all falls out, so that means these coils can come loose and start scraping. Now one of these ones is open circuit. Now I've got muck all over it. So which side was it? It was this side, I think. This, not the green coil, but the inner copper coloured one. I'll put that cotton bud, just clean all this degreaser stuff off it, or lubricant stuff off it. Looks perfectly good. Isn't often you'd see a sign of some sort of... Oh, actually I can just see the corrosion, I think. Right where that wire there touches the coil, there's a little green dot Surprised my eyes can even see it anymore, but that will probably be a problem. I can just make out it's had a little bit of liquid or something there. Surprisingly I can't push that wire sideways. But that looks corroded to me. I'm not sure if we can lift that green. Of course the glue is all good on the bottom side. The bit I want to come loose. But anyway, I think the battery's near flat on this camera. I'm going to have to stop. Yeah, I can't. Oh yeah, there it is. I just pushed it sideways. Yeah, no, it's definitely disconnected there. So there was a tiny bit of corrosions. Somehow got into here. And it's eaten that wire, connecting wire, off the end of where it goes into the coil, this copper coloured coil in the middle. So that's why that's open circuit. Very fine wire. Doesn't take much, just one little bit of corrosion will eat through that in no time. So that's the problem with that lower drum. So that's possibly why this machine ended up sitting in a shed, getting covered in rain and possum urine and stuff that's absolutely destroyed it. All the circuit boards are pretty well knackered, but you could actually take these bearings out. These will knock out if you had to replace them. Don't think I've ever seen a particularly noisy bearing in these machines, even this one, although it was running a little. But now that I've taken the motor off, I think it's a bit eccentric because I'm not in, but that should spin nicely. Normally when you spin the heads they'll just keep going. So I don't think the bearings are faulty in this. But it could have even been that copper wire because it's come loose, could have been dragging a bit or something. That shouldn't add much friction, but it might. I'm not sure how corrosion would have got in there, but from the look of it, if something gets on top of this head here, those holes that could go right down through the ferrite on the top and then land roughly about there. Yeah, it's about the right spot. I reckon something's gone down through the top of these heads, got onto the lower coil, just some little bit of moisture or muck. But given this condition this machine's in, it's a wonder it's not far worse. So that pretty much concludes this video on having a look at what these old mechanisms are made out of. They did get progressively simpler in a way with the newer machines. Things like instead of having a separate capstan motor and flywheel driven with a belt in between them, they just have a direct drive like a brushless motor for the capstan motor. And I think some of them, even the reel motors, yeah, the reel started coming off the capstan motor as well, off a pulley on the back. So they got rid of the reel motor, didn't completely get rid of the capstan motor, but combined it into a single unit. And so they gradually made these a bit simpler and a bit cheaper to manufacture as well, without losing too much quality in the beginning, although they did get gradually cheaper once the Koreans and Chinese and stuff started making video mechanisms, and basically the Japanese had to compete with that. They sort of had to market to themselves with these early ones, so very solidly built but probably a bit over engineered in hindsight really, but that was kind of how they did it back then. That was what the technology was. So the next video we'll have a look at actually repairing one of these. I've got a machine that isn't all damaged like this one, hasn't been out in the weather and stuff, so we'll have a look at that and actually diagnosing the sort of common problems. It's bound to have a few of the common things. Definitely be due for a belt kit. Most of the old machines, you definitely want to put a new belt kit in them if you're fixing them up just as routine maintenance, because especially if they've been sitting around for quite a while, you'll probably find you'll have to these days. But I used to buy a lot of these machines second hand, not working, and fix them up, and it was basically you put a new sensor lamp in, replace all the belts, give them a service, and send them out the door again, and that would fix, 9 out of 10 of them. There'd always be one with a weird electronic problem or something in it out of that batch, and you might find a few minor things like little mechanical counters don't work, or maybe there is one of these motors faulty or heads worn or whatever, so you'd kind of cannibalise one with a difficult problem in it or an electronic problem and fix the other ones with that. But pretty rare you'd get anything like that. Normally it's pretty routine maintenance on these things. So we'll have a look at this machine I've got. I'll be 90% sure it's going to be something simple, and probably just maybe a sensor lamp, definitely a belt kit, and that'll probably be about it for that. So we'll have a look at that, and that'll be part 2, and thanks for watching.